On this video, we're going to take a look at similar polygons again, but this time we're going to look at their sides. So in the previous video, we were looking at similar polygons and their angles. So now, similar polygons have, remember, exactly the same size or the same shape. They can differ only in size. So their shape needs to be the same. I can't have, a triangle and a square that I'm comparing. It needs to be triangle and triangle and the exact same triangle. The only thing I can change is I can either make it larger or make it smaller. So in similar polygons, the measure of the lengths of the corresponding sides are proportional. Okay, so what that means is we're going to take a look at the side lengths when we're given a polygon. So in this case, we're given quadrilaterals, which means four-sided figures, and hopefully we can see these are in fact the same looking figures, just this one's a little smaller than this one. So we have JKLM and PQRS, and they are similar, which means the angles, the corresponding angles, will be congruent. So I can match up the angles here. They will be exactly the same angle measure. But the side lengths will all change. They'll all either increase or decrease by the same factor. Okay. So if I compare the side lengths, I can find a missing side length. So if you notice, I have all the side lengths filled in for JKLM. I have a side length for each one, but for PQRS, I'm missing PQ. So that means, they gave me an X there. So I can use my proportion, the idea that I know that they're proportional, to find that missing side length. So I want one full fraction. So I'm going to go through and I'm just going to kind of highlight with some colors here to show you, how the sides compare. So you can see I've highlighted these two sides blue. So these two are corresponding sides. And then I have my two kind of left top-ish sides there, which I did in red, and then my two orange sides, which is kind of the bottom left, and then the very bottom of each figure I did in pink here. So I just highlighted it in different colors so I can very quickly kind of reference those colors. So when we build our proportion, we want at least one completed fraction, and then the other fraction needs to include the side we don't know. So I know I'm going to have the two red sides as one of my fraction, but then I can pick any of the other three sides that are already filled in. Okay, so I just went ahead and went with the blue sides here. So I went KL and QR. I could have gone with the two orange. I could have gone with the two pink. It would not have changed the outcome when we get to the end of the problem. Okay, I still would have arrived at the same answer. And I'm going to compare that to the two red lengths because KJ and QP is the one that I need, right? And if you notice, pay attention to how I did this. KL, that's on the larger figure, and KJ is also on the larger figure. So it's larger figure and larger figure, and then the smaller figure and the smaller figure. So I didn't mix my fractions. I didn't change, which one was on top and which one was on the bottom. If I chose from the top first, I need to choose from the top first on the second fraction to have the appropriate proportion. So now we're going to substitute the actual lengths in here. So KL is 7 and QR is 5.6. So I can just grab that straight from the diagram. KJ, that's 5. And then QP, that's my X, right? That's the one I don't know. So now I'm going to solve this with cross multiplication. So I'm going to go across from top to bottom, from left to right, 7 times X. And then I'm going to do the same thing the opposite direction here, from right to left. And I have 5.6 times 5. Again, when we're doing cross multiplication, this is just a simplification method. When I have a proportion, it's still equal to each other. It's really getting rid of these fractions in kind of two simple steps there by cross multiplying. So I have 7x, which is going to simplify to 7x, 7 times x, and then 5.6 times 5, well, that gives me 28. And now to get x by itself, I just have to divide by 7 because I want to undo the multiplication here. So I'm going to divide by 7 on both sides. 7 divided by 7 cancels. It just becomes x. 28 divided by 7 is 4. So this is using proportions to find a missing length on similar polygons. I hope that helped, and I'll see you in the next video.